NASA used nearly 500,000 gallons of water in just 60 seconds to successfully launch a powerful rocket. But why do rocket launches require so much water? The billowing clouds of water vapor you see when spacecraft take flight come from two sources. The first is its launch systems. You know, that gigantic rocket the spacecraft is attached to. These rockets are commonly powered by a combination of liquid hydrogen and liquid oxygen. Some of the vapor that you see during a launch is caused by the supercooled liquid fuel turning into gas when the overpressure is bled off just before launch, along with water vapor forming as it condenses around the O2 and H2. The second primary source of water vapor comes from the launch pad's sound and fire suppression systems. Engineers foresaw that the sheer amount of acoustic energy generated by a launch would be enough to damage the sensitive, extremely expensive onboard electronic equipment. They arrived at a relatively cost-efficient solution: water. Right before a launch, massive amounts of water are ejected from a nearby tank to minimize this damage and prevent fires from starting on the launch pad. Sound travels in the air as waves and has two key characteristics: frequency and amplitude. Frequency refers to the number of times per second a sound pressure wave repeats or oscillates. Depending on how fast the sound wave oscillates, it can vary in timbre from rich and bassy to shrill and harsh. Amplitude, on the other hand, is the displacement or distance moved by a point on a wave. The louder the sound, the stronger its corresponding sound waves. With a stronger sound wave, a stronger vibration is produced, so you can imagine the damage that a rocket producing 8.4 million pounds of thrust could cause just from sound vibrations. Water mitigates a good deal of the acoustic force generated by a launch by acting as a medium for the sound wave's vibrations to travel through. Instead of traveling through the air and hitting critical equipment, it goes through the water. This is how NASA is able to reduce acoustical levels on launch sites to about 142 decibels, which is within an acceptable margin for a payload or spacecraft's design requirements. That's still quite loud though, even louder than a metal band concert. NASA's latest space launch system for its Orion spacecraft comes equipped with a particularly potent sound suppression system to pair with its new rocket. As the SLS features the most powerful booster ever built, engineers saw fit to design a new, more powerful system to protect the equipment and crew on the ground. Dubbed the Ignition Overpressure Protection and Sound Suppression, or IOP/SS Water Deluge System. This system releases 450,000 gallons of water in just 60 seconds during launch. That's enough water to supply a town of 1,000 for almost 6 whole days. Yet each drop of it is essential for a launch's success. Launches need as much water as possible, since a large amount of it evaporates instantly under the extreme heat of a rocket's jets. While this may seem wasteful to some, NASA is acutely aware of the amount of water consumed during these launch events. They have a water resources program, which does important work in the water resources management community. Some of their projects include creating more accurate stream flow forecasts in the Sierra Nevada and Colorado River basins. They also utilize their vast resources to study how phenomena such as climate change and overpopulation affect water supply around the world. So the next time you stumble across a video of a rocket launch, you should be grateful you're not able to truly hear it.